In the grand theater of the cosmos, few ideas are as captivating as the wormhole, a theoretical shortcut through the very fabric of space and time. Born from the mathematics of Albert Einstein's general relativity, a wormhole is an Einstein-Rosen bridge, a tunnel connecting two distant points. Imagine folding a map so that your starting point and destination touch, then punching a hole through them. That's the idea. If they exist, we'd likely find these cosmic doorways in the most extreme environments imaginable, with the crushing heart of a black hole serving as a potential entrance. But there's a critical catch. Any natural wormhole would be catastrophically unstable, collapsing in on itself faster than light could pass through. It's a door that slams shut the instant it opens. To hold it open, we would need something straight out of science fiction. Exotic matter, a hypothetical substance with anti-gravity properties that could theoretically prop the tunnel open long enough for safe passage. And if we could build one, could we travel in time? Theoretically, yes. Here's how. Imagine creating a stable wormhole. You'd leave one mouth stationary, perhaps near Earth, and send the other on a journey at nearly the speed of light. Because of an effect called time dilation, time would pass much slower for the traveling mouth. When you bring it back, the two ends would be connected to the same location, but separated by years, or even decades. You would have a bridge connecting not just two places, but two different moments in time. Step into the younger mouth, and you'd emerge from the older one, arriving in your own past. Of course, this raises mind-bending paradoxes. Could you change history? Or would you simply create a new, parallel timeline? For now, wormholes remain on the far edge of physics. They are not something we have seen, but a profound what-if, born from our deepest equations, a tantalizing dream of a universe where the rules of distance and time might just be breakable.